Chapter 16, Sterile Storage and Transport. Learning Objectives. As a result of successfully completing this chapter, readers will be able to review basic sterile storage considerations. 2. Describe basic types of sterile storage shelving. 3. Identify procedures for moving sterile items into storage. 4. Explain the concept of event-related sterility. 5. Discuss the basic storage guidelines. 6. Discuss other sterile storage and transport concerns, such as basic procedures for cleaning sterile storage areas, sterile storage personnel, transporting sterile items, and transport guidelines. Introduction. A great deal of work goes into ensuring items are sterile and ready for patient use. Once items are sterile, they can easily become contaminated. Extreme caution must be exercised to keep each sterile item safe until it is used. While barrier packaging protects sterile items from contamination, it is not an impenetrable barrier. Sterile packages must be protected from events that can cause them to become unsterile. This is accomplished by keeping the items in a safe environment and consistently practicing good handling protocols whenever handling a sterile package. This chapter will examine strategies to help keep items sterile until used. Definition: barrier packaging. Packaging that prevents ingress of microorganisms and allows aseptic presentation of the product at the point of use. Sterile storage considerations. After sterilization or after purchased sterile items are received from an outside vendor, the items are stored until needed. The activities of personnel in the storage area and the environment itself impact the maintenance of item sterility. Just like at home, if items are not properly protected or something unexpected happens, stored items may become unusable. If there is a flood in the kitchen, for example, food items like flour or sugar in their original packaging can be ruined by water. If there is a flood in sterile storage, some or all of the packaged items may be ruined. Healthcare sterile package storage areas need to be well planned and constantly maintained to keep items sterile until used. The sterile storage process actually starts as soon as the sterilizer door opens, at the end of the cycle, or when purchased sterile supplies are received into the facility. See Figure 16.1. Protecting sterile items from contamination begins with considering the environment where the items will be stored. Providing the proper environment is critical to maintaining sterility. The following are all considerations that must be addressed when determining an appropriate sterile storage area. Location. The sterile storage area should be located next to or near the sterilization cooling area. This area should ideally be an enclosed room, easily accessible from the sterilization breakout and case cart staging areas, while being out of the facility's main traffic area. The storage location should be removed from the general traffic flow patterns to minimize airborne contaminants and keep items away from untrained personnel. See 16.2. Definition: breakout. The process of removing commercially sterilized items from their outer shipping containers in an area adjacent to the storage area to prevent contamination that is present on the containers from being introduced into the storage area. This area should be designed and designated for storage of sterile items only. Non-sterile items should not be stored in the area as they could contaminate sterile packaging. While it may be impossible to create a separate sterile storage area, every effort should be made to place items in the area that meets criteria for sterility maintenance. It must be noted that sterile items may be stored in other areas of the healthcare facility, such as nursing units, etc. Space. When addressing space, when designing or selecting an area for sterile storage, it is important to be sure there's adequate space for storage and cart movement. When considering floor space needed for proper storage of the flow of following materials must be considered. Type and number of instrument trays to be stored. A rigid container usually requires more space than a wrapped tray. However, containers may be stacked on top of each other while wrapped trays cannot be stacked. Adequate space for smaller items in peel packages to allow for appropriate storage techniques. Adequate space to store purchased pre-sterilized items such as surgery procedure packs, gowns, and sterile supplies for distribution. Adequate room between aisles to allow for cart movement up and down the aisles and to allow for enough space for easy access to all shelves. The room setup should allow for a thorough cleaning and room for future growth. Storage conditions. Sterile storage areas should have no exposed water, sewer, or air conditioning lines that could leak and contaminate the items. Work surfaces should be made of easy to clean, smooth, and durable material. There should be no exposed light fixtures, pipes, or ducts that can collect or shed dust. The area should be physically separated from the other areas of the department. If this is not possible, extra care is required, so air and traffic always flows from the sterile to the clean, from the sterile to clean to dirty. No pass-through traffic should be permitted. Air supplied to the storage areas should be as clean and dust-free as possible, and this usually requires filtration. Because this area will store sterile items, air pressure should be positive in relation to surrounding areas so air flows out of the area when a door is opened, reducing the chance of airborne contamination. The room should also have at least 4 complete air exchanges per hour. Temperature in the sterile storage area may be as high as 75 degrees Fahrenheit or 24 degrees Celsius, with less than 70% relative humidity. Very dry air can affect seals and cause plastic materials to become brittle. Excessive humidity can cause tapes and labels to lose their adhesion, loosen seals, or affect package content identification. Moisture can also condense on the packaging material and seep or wick through it while carrying microorganisms to compromise pack sterility, leading to wet packs. Moisture also provides an excellent opportunity for fungal growth through the packages. It is important to keep packs at least 2 inches away from the exterior walls, windows, and window seals where condensation can form on interior surfaces of exterior walls. Temperature and humidity levels should be checked and recorded at least daily. See figure 16.4. This area should have proper lighting so package labels can be easily read. The recommended lighting for this area is 200 to 500 lux. There should be no dark corners or blind spots, which could lead to improper product identification and misplaced or forgotten inventory. Adequate lighting is also critical for personal safety. Definition: lux, a unit of illumination equal to 1 lumen per square meter. A hand-wash sink or hand sanitizer dispenser should be located in this area. If installing a sink, do not place a sink too close to the shelving units, as water splash could contaminate the sterile packaging. Storage shelving. Many companies manufacture shelving that is appropriate for storing sterile supplies. Some facilities have custom-made shelving units to properly fit their allotted space. Regardless of the shelving type, there are several things to consider when choosing or replacing shelving. See figure 16.5. Things to consider. Storage shelving should be designed to protect the sterile product. Shelving should be sized to properly fit the stored items without product overhang. Trays that do not properly fit on the shelf pose a safety hazard to all who work in the area. Trays that overhang shelving may also become contaminated by people walking by and brushing against them. Shelving must be designed to easily hold the total weight of the trays to be stored. Shelving should also be ergonomically friendly for central service technicians. Shelving should allow for easy access to the stored product. Shelving must be easily cleaned. Metal or plastic shelving is recommended for this reason. Porous materials such as wood should not be used as it cannot be properly cleaned and can harbor microorganisms. Closed shelving. Closed shelving is the most preferred type of shelving because it protects the sterile packaging from dust, traffic airflow, as well as other environmental and physical challenges within the storage area. See figure 16.6. Shelves are usually constructed as solid units, allowing for secure storage and easy cleaning. Closed shelving is expensive, so many facilities do not use this system, or it is used only for the most delicate and expensive items. Doors should be kept closed at all times unless items are being accessed. When opening the doors, they should be opened slowly to avoid causing shift air currents that could potentially contaminate the sterile product. Semi-closed shelving. Semi-closed shelving is shelving that has at least 3 solid sides, top and 2 sides, and forms a closed unit when the shelves are moved together. These units are usually on track or have independent wheels. See figure 16.7 for an example of that. This type of shelving is also expensive. However, it is very good, very versatile, user-friendly, and offers good protection for shelved items. Shelves may be solid or open wire shelves. The bottom shelf must be solid to protect the stored items from contamination. The units should be pushed to the closed position when not accessing sterile product. Open shelving. In open shelf storage systems, items are placed on shelves that are not enclosed. Shelves usually have open racks to prevent dust accumulation. However, the bottom shelf must be solid to protect the stored items from contamination. Open shelving is convenient and less expensive than closed shelving. However, packages are more vulnerable to physical hazards, usually accidental, and environmental challenges from cleaning solutions and microorganisms. Regardless of the system in use, there are few standards that must be followed. First, the bottom shelf of each unit must be between 8 and 10 inches from the floor. This protects stored items from contamination due to floor cleaning agents and dust. The bottom shelf must be solid to protect items from environmental cleaning. If the shelf itself is not solid, commercially purchased shelf liners may be purchased to line the bottom of that shelf. See figure 16.8. Although not required, having solid top shelves will help protect sterile items from dust. And finally, all shelves must be cleaned regularly. Cleaning is discussed later in this chapter. Receipt of sterile items into storage. As previously stated, the sterile storage process starts when the sterilizer door is opened, after a cycle, or upon receipt of a purchased pre-sterilized item. In-house sterilized items. Once items are removed from the sterilizer, they should be moved into a designated cooling area. See figure 16.9. This area should be close to the sterilizers because moving the warm cart causes air currents to flow over the warm items. Since the room is cooler than the sterilized items, this movement can cause condensation, making the items unsterile. Air currents can also help microbes penetrate the warm packaging material, again contaminating the sterilized packages. Packages should not be touched until they reach ambient room temperature. Touching warm packages can cause the packages to become contaminated from microbes on the skin, transferring through the warm package material. A temperature meter, such as an infrared meter, is designed to determine the temperature of a package without touching the package. See figure 16.10. Once items are properly cooled, they may be placed on the storage shelf. Carefully check each item prior to placing it on the shelf. Ensure the indicator, tape, peel package seal, or container locks are intact. Physical chemical indicators, CIs, should show appropriate color change. There should be no holes or tearing in the package material. Lift, do not drag, wrap trays. Dragging will cause holes or tears in the packaging material. Wrap trays should not be stacked on top of one of each other, as stacking causes the lower trays to compress. See figures 16.11 and 16.12. When the upper trays are removed, air will be pulled into the lower packages, causing contamination. Stacking wrap trays may also cause holes in the wrapper of the lower trays. Rigid container systems may be stacked. However, do not stack them too high, as the weight may damage the gaskets on the lower trays. Trays may also be damaged from the weight. Stacking trays too high can also be a safety hazard. Consult the container manufacturer for specific instructions.